Is internal energy constant during an isobaric process? Imagine you are heating a pot of water on the stove. The pressure stays the same, but the water heats up and expands. What happens to the energy inside the water? That's what we're exploring today. In a process where pressure remains constant, called an isobaric process, the volume of the system can change. When heat is added, the water's temperature rises and it expands. Because temperature is directly linked to the internal energy of gases, this means the internal energy also changes. Internal energy is the total energy stored within a system. It includes the energy of molecules moving and the potential energy between molecules. For gases, especially ideal gases, internal energy depends mainly on temperature. So, when temperature changes, internal energy changes too. During an isobaric process, heat enters or leaves the system. If heat is added, part of it goes into increasing the internal energy, raising the temperature. The rest is used to do work by expanding the system. This work is the energy needed to push the surroundings as the volume grows. The first law of thermodynamics helps clarify this. It states that the heat added to the system equals the change in internal energy plus the work done by the system. Mathematically, it looks like this. Heat added equals change in internal energy plus work done. In the case of an ideal gas, the change in internal energy can be calculated by multiplying the number of moles, the specific heat at constant volume, and the change in temperature. Since the temperature increases during an isobaric process, the internal energy also increases. Think about boiling water at atmospheric pressure. As heat is added, the water's temperature rises, it expands, and the system does work by pushing the container's walls. The internal energy increases because the molecules move faster at higher temperatures. So, to answer the question directly, no, the internal energy is not constant during an isobaric process. It changes because the temperature of the system changes. The heat added increases the internal energy, but some of it is used to do work as the system expands. This is why internal energy depends on temperature, and during an isobaric process, it always shifts as the system heats up or cools down.